combination of real and imaginary values are a mix of the two, both exponential and sinusoidal motion. Even though both poles and zeros of the system are needed to characterize the response to a forced input, only the poles of the system are needed to dictate the unforced response to a set of initial conditions. And this ties directly to the stability of the system. And that's why when we're talking about stability of the system, we're really only looking at the poles in the transfer function. So knowing the location of the poles in the S-plane not only help you determine stability of the system, but also whether response will be oscillatory and at what frequency, or exponential and at what rate. But there's even more information hidden in this graph. A third set of lines that can be drawn on this chart as well. These are lines of constant damping ratio. And they radiate out from the origin at a value of cosine. So two separate poles on these lines have the exact same damping ratio. Let me give you a quick side note. Don't be confused between the term damping ratio and the term damping coefficient. They aren't equal. The damping coefficient is the value of the damping term, or Newton seconds per meter, so that when you multiply it by a velocity, you're going to get force out. This damping coefficient can have any number of values based on the size of the system. The damping ratio, on the other hand, is a normalized unitless damping value, so that a 0 corresponds to no damping at all, which as expected puts the poles on the imaginary axis, and a 1 means perfectly damped, so that there's only exponential motion, which puts the pole on the real axis. And anything greater than 1 means overdamped. It's more like a damping percentage, not a damping total. And it's that damping ratio that can be seen easily in the S-plane. So you might be asking, why did I explain all of this information to you instead of talking about the root locus method like the video title says that I should? Well, because it's important in understanding the usefulness of the root locus method. Control engineers have to design control systems to a set of requirements. And a lot of the time, those requirements come in the form of damping ratio, exponential growth or decay, or natural frequency of the system. For example, one of the requirements could be that the damping ratio has to be greater than some value. If it's stated like that, that means that the poles of the system have to be inside this pink cone, or less than that damping ratio. If you're given a requirement about time to half, this means that the load must decay to half its value within a certain amount of time. And since the further a pole is from the origin, the faster it decays, then in order to meet that requirement, all of the roots or the poles must be to the left of that particular time to half line. And finally, if you're given a natural frequency requirement, like the mode has to be slower than 1 radian per second, then the poles have to fall within this yellow band, or slower than 1 radian per second. And of course, more often than not, you're going to get some combination of these requirements. And so you can just build them up and determine where the poles of the system need to lie in the S-plane. So, now that we understand how pole locations affect the system, let's get back to the root locus method and their design questions. Let's say that you want to design a mass spring damper system that meets certain requirements. And we'll say that the requirement is that the damping ratio for the system must be greater than or equal to 0.75. However, you don't have control over the entire design. The spring department is in charge of choosing a spring, and it gets to pick the spring constant, which they pick as 1. And the mass was developed by your marketing department, and they said that a mass of 1 would sell the best. So now you get to pick your own damper, and with any damping coefficient you need in order to meet the system requirements. So your transfer function for this system, from input u of t to output x of t, would look something like this. And notice that I left the unknown damping coefficient b as a variable in this transfer function. Now the root locus method gives us a way to plot how the poles of this system move in the S-plane as we take the unknown parameter b and sweep it from 0 to infinity. Now this lecture isn't going to focus on how to draw the root locus plot, just on how to interpret it and use it. Drawing a root locus by hand is useful. However, most of the time you'll just use a software package to draw the root locus for you. Now here's what the root locus would look like in this system. As you can see, the poles start here when D equals 0, which is undamped oscillation, exactly as you would expect from zero damping. And as we increase the damping, the poles move further into the left half plane, which indicates the critical damping value, where the two poles split and separate on the real line. So now at this point, I can draw my two lines of constant damping ratio at 0.75. And I know that I need to pick a value of B that puts the poles of this transfer function somewhere along that blue line. I'm going to choose a value of these yellow x's, because this allows me to buy the smallest, lightest damper I can while still meeting system requirements. And so we need a damping coefficient of 1.5. I wrote zeta equals 1.5, but I really meant B equals 1.5. However, you're about to ship your spring mass dampers out to your customers all over the world when the spring department comes running to you in a panic and says that the spring constant changes when it's subjected to temperature variations. When the spring gets really hot, the coefficient drops to 90% of its normal value, and when they get cold, the coefficient's raised to 110%. So we need to know how sensitive is our design to this variation. And now we can use the root locus method to determine how sensitive the system is to changes in the spring constant. You can replace the spring constant with a variable k in the transfer function. Then either manually or with a software package, you can run the root locus with k varying from 90% to 110% of the ideal spring constant. And when you do that, you'll see the following graph in the S-plane. First, let me redraw our requirement, which is the lines of constant damping ratio. These yellow x's are our ideal spring constant at 1, and these red lines that I'm drawing is the root locus, where it goes from the hot value of 0.9K to the cold value of 1.1K. And you see that when the springs are hot, we still meet our requirement. However, when they're cold, the damping ratio goes down to 0.715, which doesn't meet our requirement. And now your team has a decision to make. Do you restrict the operating temperature on the low end so that the device still performs, or do you add a warning that performance will be degraded in low temperatures, or do you call back all of your parts and redesign it so that it works for all reasonable temperatures? Unfortunately, the root locus method can't help us with that. But watching how the roots move through the S-plane is powerful, and the root locus method helps us do that. And if you have access to a program like MATLAB, then you can generate root locus plots easily and interpret the results quickly. However, when Walter Evans developed this method 60 years ago, there was no MATLAB, and manually calculating the roots of the system for multiple values of k was time-consuming. So there are a set of rules that you can follow to manually draw the root locus. And like I said earlier, it's good to know how to do this because you can start to imagine how adding feedback or upping the gain in the system will move the poles without actually ever having to model anything. And ultimately, it'll help you become more familiar with your system and make you a better controls engineer. I'll cover the rules for drawing a root locus in another video. So that's all I have for right now. If you have any questions or comments on what I've stated, leave them below and I'll do my best to get back to you and answer them. Also, don't forget to subscribe so you don't miss any future videos, and I'm on Twitter at Brian B. Douglas. Thanks again for watching. See you next week.
He will come next week. So our class is finished.
This is introduce what is importance or how the importance of root locus. Yes. Now, but we how to give this root locus of a computer system. It should be give it step by step. So we should go on our chapter 4. Root locus method. Now, it was very easy for us. So we should go on.
It's easy for you.
So we can should review what we have done last week. First, we review the rules of this drawing root locus. How to give a root locus. It is by your hand. give you by hand, not by MATLAB or computer. So if we by our hand to give these rules, we should do according to the rules as this. So the first rule is the symmetry of the root loops. We can see here the root loop must be symmetrical with respect to the horizontal real axis. With it is symmetry, and with respect to the horizontal real axis, because complex roots must appear as pair of complex conjugate roots, because it is pairs of complex conjugate roots. So the root locus must be symmetrical. This is the first rule.
Lockdown is our it was quite much. I must not say lot only
The second is the start point and the end point. The start point starts from poles and end at zeros. So this root locus start point
London already lockdown.
start from poles and then end point. It is zeros. The second is the start point and the end point. You can see here. This is JJ and PI. P is open loop poles and JJ is open loop through loop. And the third rule is the root loops on the real axis. Third, root loops on real axis. The fourth is the asymptote of the root loops. The asymptotes should be given this point, and at the same time the angle. So they are asymptotes. Potatoes. So it is being called point. First, the point, and the second should give the angle. The angle. The point on axis, on real axis, it is decided by this formula. Theta I equal to sigma pi and minus sigma jj by m minus m. So this formula determines this localization of the point on the real axis, and the angle of the asymptote real with respect to the real axis is right as say equal to 2k plus 1 by m minus m times pi. Here k is from 0, 1 is to m minus m minus 1.
Yes.
So this is a real 4. The first rule is about the asymptote of this root locus. You can see here. For this figure, there are three asymptotes. The asymptotes are all on this real axis, and the angle is pi by 3, pi multiplied by 3 angle, and have the same point, -1. The fifth is this breakaway point of the rotors. For breakaway point, the rotors left the real axis at a breakaway point. The breakaway point on the real axis can be evaluated graphically or analytically. The locus leaves the real axis where there are a multiplicity of roots, typically two. The fifth root. For example, this is the breakaway point of the following functional function. And the sixth root is this roots cross the imaginary axis. Point across imaginary axis. Point cross how to compute it? We can compute it by this two equation. What? What day is December? Did we have done last class? Have done it?
No.
No, not done.
I'm going to
Where is the figure?
this one.
This one. Okay. Now we show the point where the locus cross the imaginary axis. Now let's go. But we do it. How to compute it? We should first give this two equations.
Yes, ma'am.
Imaginary part
And
the real part.
Yes. Yes, that. Base of this. 0. This one. 5. Amin.
Oh. It is equal to 0. You should to continue to write. One plus GSH is equal to 0, and then S is substituted by I omega, and then we cannot the real part and the imaginary part of 1 plus GSH is equal to 0. Then we can get this in the sixth import, or cross product. Real part for imaginary part.
Actually, we set up the data camera. What's the name? I just want to teach something I really big.
How are you finishing?
You finish it, class.
You're finished. Let me see. We try?
Yes.
Then please go.
That day you were done with this one. Right.
We got to be. Kill it.
One plus G is equals equal to 0. So this is 0. This is 3 minus 1 plus K is plus 5 and S square plus 4 plus 8 is 0. And then S square plus 4S plus 8 plus 3 is plus 5 equal to 0. Oh, and then S 2 S and 5 equal to 0. And then we need S is substituted by I omega. Then this is minus omega 2 I minus 4 omega square plus 3 omega I plus 5 equal to 0. Next, the real part is this. So, minus 4 omega square plus 5k equals to 0. And then minus plus omega equal to 0. Then we should solve this equation.
দিতে উনি নিজের হাতে লেখেন দিয়েছেন
তারপরে দিয়েছে
ওনারা আমি বললাম যে এটা আপনি সেদিন করে দিয়েছেন এটা দেখেন এটা কিন্তু সেদিন হয়ে গেছে উনি নিজের হাতে লেখেন নিজের
Are you finished?
না দিনে উনি বললো যে এটা এইভাবে আমরা কি করবো এইভাবে করে দিচ্ছি ওইটাই আবার এখানে করে দিল
This is the real part. This is imagine part.
ঠিক করবো ওইয়ের মতো না হ্যাঁ ওইয়ের মতো কে বলছে না বলছিলেন
This is equal to 0. Equal to 0. And that has no limit. From 0, yeah, yes, equal to 0. That's true. We can the root of this equation.
So this finish.
No, at home. What? This omega equal to what?
Oh, I have to find only color.
And k equal to what?
বিভিন্ন করছিলাম বলতে
এটা তো আমি যদি মাত্র যে জায়গায় গেছি না ওই জায়গা থেকে আনছি সাবানে কিছু দাঁড়িয়ে
ঠিক আছে কত অনেক
কি আছে
নাসিমের বাচ্চা নাসিম উঠলে বুঝতে দেবেন খুঁজতে হবে
এই কত সুন্দর করে দেখে সুন্দর
তোমাদের ঠিক করে হাঁটতে হবে না
তো একটা ইউজ করলে সমস্যা নেই
ঠিক আছে তাহলে আমরা কত
আজকে শুরু করতে খুব ভালো লাগে তো
কাজতে চলে না সেটা আচ্ছা কি আছে এই হাসি কথা বলতে
ঠান্ডা করবো
ये सब फाइव तो सब सही है हाँ
হাসবো না কানবো কোনটা কি করবো
হাসতেছি তাতে ওরা দোষ রেখেছে
আমরা তাইলে অন্য কিছু করি না অন্য কিছু করি আমরা নাকি
চলো যাই বসো আর হাসবো দিয়ে
ছবিটা দেখি আমরা
By this equation, omega equal to what? Omega equal to
root over 5 over
y square equal to
5 okay so omega equal
and then this equation it is omega minus omega square plus
এটা 9 8 না
8 plus k omega equal to 0.
হলো yes
And if omega equal what is 0, then it equals
তাহলে এটা 9 8 না
and then omega square equal to this.
yes
So it is minus 5 by 4 k plus 8 equal to 0. So this k equal to what?
so Rashi how can we prove this omega and we write that this square
Yeah.
I don't know
It is divided by
oh
omega.
I understand
So here is minus omega square. Omega square equal to this part.
let's put this value and k equal 1 32
Yes.
32
K is 62.
কি এসে কি করছে ওমেগা করছে না
তো তো ছিল না তো omega এটা দাম হবে জেনে জেনে এটা সেমেটা omega বলে
এটা 0 হচ্ছে
Now let's do it step by step on the blackboard.
তো
And
এটা এটা লসের দাম বলবো না
ওটা পুরো উপরেটা 0 ওই নিচেরটা 0 হয়ে যাবে গুণ করব না
তাহলে এটা যদি এটা অনেক গুণ করতে পারছি তাহলে আর কি কাজটা হবে
হ্যাঁ আবার খালি এসে তার
কি কিছু তুমি আমাদের
এটা হচ্ছে এটা আনসার কি এটা দুই মাস দুই মাস কোনটা
এটা নিয়ে তো করে খালি করে
কোনটা এটা
এটা দিয়ে পাবে
We should remember this 1 plus gs hs equal to 0. And then here gs hs equal to k times s plus 5 s times s square plus 4s plus 8 fit
উপরে নিচে দিলে
square. We should do according
সাইডের দিকে
one the characteristic equation here. Then we can get 1 plus gs hs equal to 1 plus k s plus 5 by s square plus 4s plus 8. Now, it is equal to 0. So, on the right hand left of this equation, we times s and s square plus 4s plus 8 at the same time. So, in this equation, we can get s square plus
শিরোনাম বাই করে
4s square plus 8 plus ks plus 5k equal to 0. Equal to 0. And here s is substituted by I omega. Why I omega? Because this cross point on the imaginary axis. So we should note s is substituted by I omega in this equation. Then we can get I omega curve plus 4 I omega square plus 8 I omega and then plus 5k equal to 0. Equal to 0. Let's go on. Here I square equal to minus 1. Minus 1. So we get omega curve minus omega I plus minus 4 omega square and plus plus 5k equal to 0. For the equation, we have real part and imaginary part.
Yes.
And the real part and the imaginary part are all 0 at the same time.
Yes.
So we can get the following two equations. The first the real part of the equation is
minus omega square
real part is minus 4 omega square
plus
plus 5k equal to
0
0. And the imaginary part
minus omega cube
is minus omega square cube plus
8 plus k
8 plus k
times omega times 0.
into 0. So from the first equation, we can get omega square equal to 5 by 4
k
k. And for this equation, if omega equal not this equation, if the omega is not 0, then this equation we can get is
minus omega square
minus
8 plus k.
K plus 8 equal to 0. We can see here, this omega equal to
5 over 4.
5 by 4k. So 5 by 4k. Here minus plus k plus 8. Now equal to
0.
minus 1 by 4k plus 8 equal to 0. So k equal to what?
32.
32. K is 32. K is 32. We can see here. Omega square equal to 1 by 4k. So omega square equal to 5 by 4 times
32.
32.
40.
And then it equal to
40.
40. So this omega equal to what?
Omega. 1 minute. 2 yes.
And this cross point in the imaginary part, so it is can be write as 1, 2, or S1 equal
2 root 10.
to 2, S2
Minus 2 root 10.
Okay, so this is the point where the look cross this major point, and this procedure tell us how to get this point.
Yes.
Okay, have it. For the asymptotes, we also discussed the angles. The angles is between two lines, straight lines. Now we can see for the real 7, the angles between the directing of images or entry of Q coincident points or zeros on the real axis. Now, this discusses this immediate angle or anti-angle. We can see it is immediate. Or anti-angle. Angles. What kind of angles you can see? For every 2 poles, there must be a pair of the point. We can see here, this has 2 root loops on this place. And here, there are 2 angles. One is upside, and this another is the downstairs. We can see. And then for the third is on the right, on the left hand. Let's see. For this point, there are 3 poles. The 3 poles, they have the 3 angles. The angles 1, we can see here, it is this direction and with this real axis. The second and the third, 3 directions, 3 angles. This is our imagined angles. These angles, how to get it, how to compute it. This theta equal to 2k plus 1 and
n minus n.
q by pi by q and times pi. And for this And for the next, it's also 3 angles. We should what? That is also give an example.
আসল ঠিক করবে তখন
আসল শীত এই মাসের লাস্টে ও বাইরে শীত করবে
12 থেকে ক্লাস সেখানে সকালে ক্লাস দেন না আমাদের
এই তো মশা
একদিন ক্লাস কখন আমাদের বিকেলে নিতে হবে রাত্রে
টেকনিক্যাল ক্লাসে তো বিকাল রাত্রে
রাত 9টা থেকে নেবে 9টা থেকে
10 তো 1 ঘন্টা নাস্তার সময় শুরু হইব 12টার সময় শেষ করবো শেষ করে আমরা রান্না বান্না করবো সবাই খাওয়া দাওয়া করে ঘুম পরের দিন বিকাল ঘুম
হ্যাঁ
ঠিক আছে ঠিক আছে না
Yes,
বিয়ে করবো
see, this is example. This GS equal to K times S plus 2 and by S plus 1. And then we should give this imagined point and entry point. Angle, entry angle.
এটাই কি 1 প্লাস জিএস এইটা লিখতে হবে হ্যাঁ এটা লিখতে হবে এটা কি মূল সূত্র নাকি
আর কি মূল সূত্র পাতলা দিয়ে
এই জিনিস তো এটা
ইউজ নাই এটা হলো ফিডব্যাক মানে এটা ইকুয়াল আমরা এটা জানি তো এটা সংযোগ করলে এটা সংযোগ করবি না কিন্তু মূল সূত্র এটা হলো 1 প্লাস জিএস এইটা ইকুয়াল
এটা কি কত 1 প্লাস কে এটা
হ্যাঁ H is equal 1. What's the system? H is equal 1.
Now, this is very easy to compute. We can see here A equal to 2 and K. Let K time that is equal to 0 or 1. So theta 1 equal to what? Theta 1, 2.
Yes.
And theta 2 equal to what? And the K is 1. So it is
3 by 2, yes.
so this is the imagined or entry angles. And the third is the departure angle or arrival angle. For this end, we will display on this blackboard. the angle of branch of the locus from complex powers and the angle of arrival at complex zero is the angle, the H, the angle of departure of the reflux from complex powers. And the angles of arrival at complex zero.
This deep path.
Yes, this the ace rules.
The
This rules is about this part. Also, it is the ace.
this deepest angle.
Yes.
D.
Arrival angle.
Deeper.
Departure. We will
Departure.
departure angle. And this arrival angle. So it is computed by this. This is the departure angle. Departure angle equal to pi. Also, you can also write 2k plus 1 pi. Is also okay. Is also okay. 2k plus 1. Also, this 1 center.
Yeah.
1 second. And minus sigma I from 1 to n. This I equal in what? From j not equal to j. Here this is sigma p j by s p I. Oh. J from 1 to n and d is not equal to I. And here this is pi minus pj and also plus sigma j from 1 to n. Here is the omega. This is the angle of pi by jj. is departure angle. And also there is arrival angle. Arrival angle. In this arrival angle, we can easily also can write as k plus 1 pi minus this sigma from j from 1 to m, and j is equal to I. We can J I by T J and then minus sigma j from 1 to m and j equal this
sigma naught is also
both equal to
J.
j also right and j I minus j all here also this is a plus. Oh. This is plus, this is minus. This two is different, so it is minus. It's in here. You can see this is what? This is the middle.
second.
What second?
So this is the eighth rules of rules to give this rubrics of computations.
Rule say it is very difficult. This one is very difficult.
Very difficult. So we should give examples.
Okay.
Okay, the best example. GSH is equal to K S plus 5 and by S square plus 4S plus 8. We
did it.
should give these zeros and powers.
For this example. 1, 2, 3, 4. N equals 4.
We should now their arrival point. We can say departure point. We can see here departure point is what? Departure point. What we first give these zeros. Z equal to what? -5. And this powers P1 equal to 0. P2 equal to
That it was S equals 0.
-2 plus 2i. And then P3 equal to -2 minus 2i. We have 4 point. Now, we should give this
শুধু আয়মান কত?
I কোনো 1 নাই, root over -1. I equal to 12 minus 4.
This that point, how to compute it?
Lucky. I don't understand. How can you get this?
How can you do this?
Yeah, this last line.
S.
Yes, so S equals 0. And another part equals also 0.
Yes.
How can you do this weird now? I can do it like this is the 4 plus 4. 4 times 1. So 4 times 2.
S squared plus 4s plus
Plus
8
8 equals
equal
0.
to S. So S squared, S plus 2. So S equal to minus 2 plus.
Oh, I feel some.
So we should compute this. Theta, Z, only one degree. So 1 degree is minus 5, and we can see that theta minus 5 equal to what? And then 2p plus 1 times pi. We can also write it pi plus sigma J I minus Pj. This J, we can see here, the angle of the angle of G minus 5 minus 1 Pj and minus plus the angle minus 5 minus 5 minus
2
minus 2 plus 2i. The second and the third angle minus 5 minus 2 minus only one angle. This is 1, 0. 2 minus j and minus is 0. This is equal to pi plus. We can see here the angle of minus 5. The angle minus 5 is pi. And the angle of this minus 3 plus 2i. And this is minus 2. This is minus 3 plus 2i. You can see these two angles. Minus 3, 1, 2, 3, minus 3 is 2. This angle. And also this angle. This is how to write it.
Lovely. Okay. Minus number of minus 2 minus 3 213.
How much?
213.
This
No, this one. Yeah. 213.
230.
13. 213. No. 213 degree.
You write 213. This angle. Minus 3.
This side.
In this side. And this on
This is the bottom.
this angle.
This angle. So this is 90. So this is 90 plus 33. So
Yeah, but these two should be this. How many is? And then
this two.
this two angle is the same. This two angle is the same.
This two, which two? This two angle.
This two angle.
is same, but this different quarter.
Different. We only compute this. How much the angle is?
33. Tan inverse.
This one angle is equal to what? It is only this part is on the
This angle is 56. You mean only this angle?
right. Minus 3 plus minus 2i plus minus 3 plus 2i. We can see here. This is
Only here.
1, 2, 3. Minus 1, minus 2, minus 3. And 1, 2,
1,
1, 2. Now, here, for this angle, this angle, this is the angle. For this,
this angle is 56.
56,
Yeah.
this also is 6,
Yeah.
the same. 50,
56.3.
1, 3,
3. 50.3. 56.3. 3 roughly.
3.
Yeah. Yeah.
This,
Also 56.
this angle,
Also 56.
this one will also same. So this angle
120.
is for this.
And this angle I have. This is 5, 120. 126.
This man.
Yeah.
And this
230. From there to there. This is 180 and this is
is what?
180 plus 236.
200. So these two angle, they summary of these two angle in the system. So this is
This pi by 2 pi. And do you know these two angles to lucky I have another question. For this pi, this k equal 1.
yes, because 2k
K
plus
equal
1
0.
is k.
Equal 0.
Is k 2k pi equal to 2 pi k times 2 pi. So this can omit.
No, I mean, you write here this 2k pi plus 1. So, this the k equals 0 here. This k equals 0, so you write this.
Oh, this is 2k pi. You can also it was to write it.
How can you write this pi?
It only this 2 pi. It is k times k. So
This k equals 0.
yes, k cycles of the it. So we can easily write it for the simplify.
Okay. And for this angle,
This
how can you
angle
write
is pi because it is only
this way.
minus root.
So this is minus, this is minus, so this here.
Not it's only in this part.
Yeah, because this x equals
have.
0, y equals 0, the x equals, so x equals minus, this minus 5, so it is here, and
Yes.
this is 0, so this is 0, so this is positive, so yes, it's right. Thank you.
Okay, you can also write theta t I is this. This is theta 0, theta minus 2 plus 2i, and theta minus 2 minus 2i can also compute it like this. It was very difficult. Now you can.
Go.
I showed to you. Next, on this Wednesday afternoon, we should do experiment.
Yes.
So they on where to building 1跟科1号楼 on the B
I'm the
Engineer.
507 my experiment number. My graduate students will tell you how to do it step by step. For experiment. Everyone, and I have almost 10 graduate students in the library, and everyone can ask for two. Two graduates can help you to do this experiment. Building 1跟科1号楼 B
They are girls or boys, Lashi?
B
They are girls or boys?
boys and girls are always okay.
Yes, love, it doesn't matter.
My graduate is very beautiful.
Really, Lashi. She is so. For him.
For him.
Yeah.
No, love, no need.
No need.
Oh,
That I showed you.
XXY.
Look at how shy he is.
See, Lashi.
And then I will give some exercises for you, and you can compute theta 0, theta minus 2 plus 2i, and theta
Ikilas alone.
minus continue. Next, this to do. By this, we should use these two formulas.
My name only like. Ikilas.
9
And next class, you can go to this building 1.
Yes, ma'am.
This B 507 directly to go to this library.
Yes.
Okay. So we have only one class, right?
2 class. The next Wednesday also do experiment.
Did you understand?
Let's choose only one classes in
Yes,
this
ma'am.
class.
সেটাই বলতেছিলাম
When they come back to Chala, the other almost 30.
We don't know.
We don't know. They cannot do experiment. Also cannot give this examination or this class.
When they will come, they will give examination.
Repeat. They will not come this year.
Next year.
Next year?
Yes.
Lashi, this
Don't
year they
know.
can come. Lashi, do you know London? London already give lockdown. Italy, London, they already give lockdown from today. London and
Yes,
Italy.
I know.
1 month long.
From Italy and London, Britain.
Yes.
They come to China.
No.
They also start lockdown.
People can go out.
Oh.
So Lashi, we are going to be wearing a mask. We have to. Last week, we can do a party in class on day or last.
Okay, you are very.
Party.
Next class.
Do you
Next
like
I need
class.
to do this.
Say so.
Last week.
And do exercises. You were very active in this class, so I think it's no problem for passing the
Last week,
examination.
he said he will give something to us. So next Monday, he give us.
Don't worry about it. It is. If we will tell you something about this.
Last you said last class you will never you. Let's set up
Kasi
the.
we will miss you lot.
Okay, if you meet you in the campus, you can say hello. It's okay.
Last week,
Um.
so you give us something next Monday.
Oh, next Monday you want to give some
Suggestion.
solution.
Last week.
Give some exercises.
Yes,
How?
ma'am.
Give some exercises. Okay? Okay?
No, last.
Are you sure?